Hi everyone, welcome back to Attacking and Defending Active Directory. We are discussing domain enumeration. Let's discuss about domain trusts. In any Active Directory environment, when we talk about trusts, there are trusts between domains and forests. A trust could be between two domains or two forests, which allows users of one domain or one forest to access resources in the other domain or the forest. uh, there are different types of trusts and different ways they are established. The trusts could be automatic, for example, parent-child trust or root node, root or leaf trust. These trusts are established automatically within a forest, or those could be established across the forest boundary. Each trust is represented by a trusted domain object, TDO. So if you recall, we discussed that everything in Active Directory is an object. Same goes for trusts. So before we start, before we start discussing types of trust, let's first understand the direction of trust. Please always keep in mind that the direction of access is reverse of the direction of trust. So for example, if this domain on the left has a trust relationship, one-way trust relationship with the domain on the right, then the direction of access would be opposite of it. The domain which trusts users coming from the other domain for its resources is called the trusting domain, and the domain uh, which is trusted by the trusting domain to allow access to its resources is called the trusted domain. So in a one-way trust, resources are in the trusting domain and users are in the trusted domain. Now, what is a one-way trust? It is a unidirectional, as the name suggests. That is, the access is just one way. In our diagram, users from this domain cannot access the resources in the trusted domain or domain on the right. So that is one-way trust. Then there is two-way trust. As the name suggests, it is bidirectional. That is, users of both the domains can access the resources in the other domain, right? Please keep in mind that when we say, even in the case of one-way trust or two-way trust, when we say can access, then uh, the users must have enough privileges to access the resources, right? Right now we are just talking about the trust. That is, it is not filtered on the trust level, but privileges of the users. Now this is about the direction of the trust. There are two directions, one way and two way. Now there is a property of trust called trust transitivity. A trust is called transitive when it can be extended to establish trusts with other domains. For example, in this diagram, you can see that domain A has a bidirectional trust with domain B, and domain B has a bidirectional trust with domain C. In case of transitive trust, this would be equivalent to the transitivity we read in mathematics. That is, if A is equals to B and B is equals to C, then A is equals to C. That is what the trust transitivity means if it is there. That is, if the domain A trusts domain B and domain B trusts domain C, then domain A and domain C would also have a bidirectional trust relationship. Which type of or what trusts have this property set? All the default trusts, that is intra-forest trust relationships, tree root, parent-child, all of these trust relationships are bidirectional transitive two-way trusts. Now, continuing our discussion with trust transitivity, there could be trusts which are non-transitive, which, as the name implies, cannot be extended to other domains in the forest. Non-transitive trusts can be one-way or two-way. Uh, this is the default trust, which is called the external trust between two domains in different forests when forests do not have a trust relationship. That is, if we have an external trust, that is a trust between non-root domains of two different forests, it is non-transitive. So these were two properties of trust which we discussed, direction and transitivity. Now let's discuss what types of trusts are there. There are some default or automatic trusts. All the intra-forest trusts, that is trusts within a forest, are automatic. If you recall, we discussed in the very beginning that Microsoft considers only forest to be the security boundary. What does that mean? That means that the trust relationship or the boundary is forest. Within a forest, if there are multiple domains, all of the trusts between those domains would be automatic. There is no need to manually establish the trust. And this trust would always be bidirectional or two-way transitive trust. Right? For example, in our lab, $corp.moneycorp.local is a child of moneycorp.local, uh, which means that there is a bidirectional, automatic bidirectional transitive trust between these two domains. So this was the parent-child trust. Then there would be tree root trust. Whenever you add a new domain to a forest or a tree, this trust is also default, automatic, and two-way transitive. For example, here in tree 1, we see that with the forest root, both of the child domains have a bidirectional transitive trust. And if we add a new tree to the forest root, there would be a bidirectional transitive trust with the new tree as well. This is the tree root trust. Now there is a special trust called shortcut trust. In some scenarios, trust relationships may become so complex that it starts impacting the access times. So in such cases, a shortcut trust can be established between two domains, which can, because it is manually established, it can be one way or two way, which reduces access times. For example, in this representative diagram, if a user from this domain wants to access a resource on the domain on the right, to reduce the hops required to access the resources, we can have a shortcut trust. Now, lastly, in domain trusts, we have external trusts. External trusts are established between two domains in different forests when forests do not have a trust relationship. That is, the root domain of the forests do not have a trust relationship. Any relationship between two non-root domains of different forests is called an external trust because it is established manually. It can be one way or two way, and it is always non-transitive. We cannot make it transitive even if we want to do so. For example, here in forest 1 and forest 2, we have different multiple domains. There is a two-way external trust from this domain to the domain of forest 2 and a one-way external trust to the same domain in forest 2. As we discussed, it could be one way or two way, and it is always called external trust. The next type of trust is a forest trust. Now, forest trust is established between root domains of a forest, right? For example, here in this diagram, we have forest 1, forest 2, and forest 3. And if there is a trust relationship between roots of these forests, it's called a forest trust. Please keep in mind, once again, it is a non-automatic trust. We need to establish it manually. Can be one way or two way, and it is always non-transitive, right? That between the forest, that is, if forest 1 and forest 2 have trust relationship, and forest 2 and forest 3 have trust relationship, it is not necessary that forest 1 and forest 3 would have a trust relationship, right? This is about different types of trust. Now let's start mapping these trusts. We can once again use Power View or the Active Directory module to map the trusts. Let's start with GetNet Domain Trust. If I run GetNet Domain Trust here, we can see that for our current domain $corp, there are three trust relationships. One is a parent-child with moneycorp.local, which is our parent domain. Another one is with US dot dollar corp, which is our child domain. And then there is an external trust with a domain called eurocorp dot local. So we have three trust relationships. Now we can always, as we discussed earlier, because it is a bidirectional trust within a forest, we can actually enumerate trusts for our child domain or parent domain as well. So for US.dollar.corp domain, there is just one trust relationship, that is with our current domain. We can do the same thing with the Active Directory module. If I run get AD trust here with a filter of asterisk, we get to have a bidirectional trust with moneycorp.local, a bidirectional trust with US.dollar.corp, and a bidirectional trust with EuroCorp, right? You like to keep in mind that the trust with EuroCorp.local would be established manually, right? Because it is an external trust with a domain in another forest. It is established bidirectional. It is not bidirectional by default. So this was about mapping domain trusts. We can also get details about the current forest. We can run, for example, get net forest from PowerView or get AD forest from the Active Directory module. Let's run both of these. So if I run get net forest here, we get the details about the forest. If I run get AD forest here, we get the details about the forest once again. We can always enumerate stuff from a trusted domain. Remember when we ran getnet domain trust here a couple of minutes back, we have a bidirectional trust relationship with eurocorp.local. That means that we can query it just like we can do for a trusted domain within a forest. We can do the same thing across forest trust as well. So if we run get AD forest for eurocorp.local, we get to know the details about that particular forest. For example, there are two domains and other information as well, right? All the enumeration we ran about computer, domain state, users, groups, whatever, all of ACLs, all of that we can, GPUs, all of that we can run against this eurocorp.local as well, right? Next, if we want to have a look at all the domains in a forest, in case of the Active Directory module, you can see that it is available right here. In case of PowerView, we can always run, it is available in case of PowerView as well, but for simplicity, there is an additional function called getNetForest domain, which provides a list of different domains in our current forest or the target forest. We can always specify an external forest as well if we have a trust with relationship. Now, excuse me, continuing with our forest mapping, we can run, if we run getnet forest catalog, for example, we'll get to have a list of all uh, those machines or all global catalogs or all machines which have a copy of the global catalog, right? So if I, once again, the information is already available. There is just an additional command to, so additional function, so that for just for convenience, so that we do not miss it, right? Another interesting commandlet here is getnet forest domain. I think we've already seen this. Okay, getnet forest trust. So what getnet forest trust does is it maps the trust for the entire domain, right? Previously we ran getnet domain trust or get AD trust from Active Directory module, which maps the trust for the current domain, whereas getnet forest trust maps the uh, trust for the entire forest. So getnet forest trust does not return anything for our current forest, as there is no trust relationship for the forest root. Let's try this with our external forest trust. Again, there is no output. Uh, okay, let's try this one. So if I run, okay, so there is no forest trust at all, which is right. Which is right because if I run this, the trust is not between moneycorp.local and eurocorp.local. Only in that case, it would be considered a forest trust because it is between a child domain and a forest root. It is an external trust and not a forest trust, right? So this allows us to have a look at, okay, before moving ahead, because I mentioned that we can actually extract information from the trusted forest as well. Let's very quickly have a look at it. We can get information like this from a trusted forest, right? So what we did, we mapped we mapped information. We mapped trust, understood what trusts are, and mapped trust relationships in our current domain within forest or across forest trust. Right. So let's have a look at some quick learning objectives. There are 4 tasks to be done, or there are 4 objectives. Enumerate all domains in the moneycorp.local forest, and then map the trusts of the $corp domain. Then map external trusts in moneycorp.local forest. Finally, identify external trusts of the $corp domain and check if you can enumerate trusts for a trusting forest. Right? Once again, feel free to use any tool you want to assess this particular or to solve this particular learning objective, right? Now, continuing our discussion with trust, whatever we have been doing up to now is very normal looking or very non uh, intrusive trust, right? We have been contacting only the domain controller. Whatever information we saw up to now, we were seeking it just from the domain controller. No other machine in the domain was contacted up to now. Now, what we are going to do now onwards in enumeration part is what we call user hunting. That is, we are going to hunt for specific users or privileges out so as to look for opportunities of lateral movement, right? And now onwards, we would be contacting other machines in the domain as well. So this is a bit intrusive and not as silent as whatever we have been doing up now. This enumeration uh, is much more noisy than whatever enumeration we have done up to now, right? So the first function we are going to have a look at is find local admin access. Find local admin access inspired from a similar script from Metasploit framework. What this particular script does, it looks for all those machines in the current domain where the current user has local admin access. Think about it. Let's say you get a foothold machine by any client-side attack or anything within a domain, and your local user, you would like to see the domain user with which you have the privilege or with which you are accessing your foothold machine. You would like to check if that user has local admin access on any other machine in the domain. This particular script is very helpful in looking for that. When you run find local admin access, this is how it works. The function requests a list of computers from the DC using getNet computer. This is one of the functions we have already seen. Then the list of the computer it gets, it goes to each and every machine in the domain and checks if the current user has local admin access on that particular machine, right? This is a very simple explanation of how it works. Go to the DC, get a list of the computers in the domain, then go to each and every machine in the domain and request a resource or check if you have local admin access there, right? This is how find local admin access works. Now, in case you want to have an additional toolkit or additional script in your tool chest, or want to actually implement your own stuff, this can be done with the help of multiple remote administration tools. For example, WMI and PowerShell remoting both are useful in such cases. Uh, Also, in some cases where, let's say, RPC is disabled or SMB is disabled, and you would still like to check for particular or for check for local administration privileges, you can run something like find WMI local admin access. So let's see if I have that script on this machine. So if I want to go for find local admin access, what this particular script does is you provide the script a list of computers in the domain, and then the script will go to each and every machine in the domain and would like to simply run a very simple WMI query. Because WMI by default needs local admin privileges, in case of an error, we understand, or the script understands that there is no local administrative privileges. But in case of a success, we know that we do have local admin privileges, right? So a very simple implementation, but very effective. Feel free to modify this to implement multi-threading, etc. Right? So this way, we enumerate for local admin privileges in a domain. Now, please keep a couple of things in mind. This is very noisy, right? We are requesting a list of all the computers from the domain controller. If even if it is a small sized domain environment with 1,000 or 2,000 nodes, we will create a good network spike by uh, contacting all the machines in the domain, right? So please be mindful of running this. There is an option with in find local admin access called computer file. So run this function in chunks for, let's say, for not more than 200 machines at a time. Also, this function leaves a 4624, which is a logon event, and a 4634 log off event on each and every machine in the domain. So please be mindful if you're running this in a red team operation, right? Now, invoke enumerate local admin is a function which looks for local admins on all machines in the domain. But interestingly, on non-DC machines, it must have administrator privileges, right? So this is useful once again for testing access for local privileges. And this is how it works. It goes to the DC, requests a list of computers, and then goes to each and every machine in the domain and tries to run getnet local group on that particular machine, right? Moving ahead with our user hunting part, uh, what if we would like, what's the easiest way or one of the easier ways of escalating privileges to domain admin? One of the very popular and easy ways is to look for a machine where a domain admin token or credential is available or a session is available, and we have local admin privileges on that particular machine, right? Let's say there is a machine where a domain admin session is established, and if we have local admin privileges on that box, what harm can we do? We can extract credentials of domain admin and escalate our privileges. And by credentials, we mean TGTs or NTLM hashes or AES keys or whatever we can get our hands on. In case of a domain environment, all of these are valid credentials, right? So invoke user hunter is a function. When we run it as a user, it looks for all the machine for a session of domain admin on all the machines in the domain and checks if we have local admin access on any of such machines. We can also use it to target a specific user or group, right? So if we are not after the domain admin, which sometimes makes sense because domain admin is generally a heavily monitored trope. So if we are after any other user or group, we can specify that. And suppose that invoke user hunter identifies, uh, I forgot to run find local admin access. I just recall that. So let me run that first. Find local admin access. Let's run with this with verbosity turned on. So according to this, we do have local admin privileges on another machine in the domain. Let's run find local admin access as well. Let's see a list of the machines in our domain, right? I'll save it to the tools directory, right? Let's call it computers. Let's load up find local WMI local admin access. Let's provide it a computer file, and let's turn on the verbosity here. So as you can see that it tries on multiple machines, found out that on dcorp admin SR with the same machine where find local admin access identified administrator privileges, it finds out that our current user has local admin access on that particular machine as well. On our own machine as well, that's our own machine, and so on, right? Let's stop this for now. Okay, coming back to this, we were discussing invoke user hunter. So this is how invoke user hunter works. As soon as we run this function, it goes to the DC and requests for two pieces of information from the DC. One is to get a list of computers using getnet computer, and another one is to get the membership of the domain admins group, right? Using getnet group member function. Armed with these two pieces of information, it goes to each and every machine in the domain and list sessions and log down users on that particular machine, that is on each and every machine, and tries to ensure or try and checks the session with the membership of the domain admins group. Let's say on this machine called comp3, it lists that there is a session, it lists the sessions and finds out that there is a session from a user who also happens to be a member of the domain admins group. Then it will tell us that domain admin token is available on comp3. That is how this particular function works, right? Without any option, it looks for membership of the domain admins group. We can specify a group or user. We can also check or confirm if we have local admin access with the help of invoke user dash check access, right? Now there is another option with this particular function, which is dash stealth. What stealth does, in place of going to all, do we have a diagram here? No. In place of going to all the computers here, it goes only for the high value targets like domain controllers, let's say, or file servers, the distributed file servers, so that less traffic is generated, right? You may like to keep in mind, like find local admin access, we are going to each and every machine in the domain. So we are going to generate a traffic anomaly if there are large number of machines in the domain and someone is looking at the traffic, right? Also, like find local admin access, we are going to leave a 4624 and 4634 on every machine in the domain. If we use the stealth option, it will not go to all the machines in the domain, but only the high value targets. But please keep in mind, it would be a bit stealthier, but also the chances of success would be lower for the stealth option. Right? So that is all about, let's run this. Once again, I forgot running that. Let's run invoke user hunter. Let's run it with verbosity turned on. So we get to see that it runs getnet computer and gets the membership of the domain admins group, And now it goes to each and every machine in the domain and tries to find out if we have local admin privileges on any machine where a domain admin token is available, right? So apart from our current machine, because we have a session to the domain controller using domain admin privileges, I don't think there is a machine where we directly have any such access. So meanwhile, this thing finishes running, we'll come back and see if there is any positive result. Uh, right. Other than our own machine, the current machine, because I have a session to the domain controller using the administrator account. Other than that, there is no such result, right? It is never going to be that easy, right? At least in our labs. I cannot guarantee about real world environments. So let's talk about a bit of defense for this domain enumeration part, right? Whatever the enumeration we have done, most of it mixes really well with the normal traffic, right? For example, getnet computer is quite similar to going here and looking at the machines in the network. Or for a getnet user is quite similar to looking for or listing users if you're trying to add some user to your local machine, right? So there is not much difference uh, when it comes to our enumeration, right? The intrusive one, the local admin access and the domain admin access, which we looked just a couple of minutes back, that is a bit intrusive, but really not easy to catch. Now there are two ways. One is to look for, that is monitor any spikes in network traffic or any 4624, 4634 from a single machine on multiple machines in a host. These are the anomalies which tools like PowerView or any similar tool create. Now, there is another way of, if not monitoring, we can actually, if we want, we can try to block or mitigate such enumeration techniques. For example, for user hunting, which was the most lethal one, which we saw just now, how can we avoid that? We can do that with a script called netcs. So how was it possible for us to, let's say, enumerate sessions on every machine? That is because whenever we log on to a domain joined machine, we get the privileges of the authenticated users group, which is not a group, it is actually a foreign security principle, but we can call it a group for now. So we get privileges of the authenticated users group, and this group has the permissions to run net session enum to enumerate sessions on any machine, right? So this is what running net session enum looks like. If I run get net session, let's say I run it on the uh, domain controller, we get a list of sessions. Right now it is just us who are connecting to this. Now if I run netcs, do I have netcs here? Let me see. Looks like I do not have netcs here. Let me quickly copy that onto the domain controller to demonstrate this. So once we have netcs on, let's copy it onto the domain controller. So let's run netcs here. Right, it says permissions successfully updated. The authenticated users group has been stripped of the permissions to call net session enum. Right, now we just need to restart service called the server service, right? So the server service has been restarted. Now if I run getNet session with verbosity turned on, we get an access denied, right? This is what the mitigation looks like. Now let's revert it so that we can continue with our enumeration. So once again, if I run this now, we can see that there are sessions established from different machines onto the DC, right? For sessions for different users. Now, one thing you may like to keep in mind, although this is a very effective enumeration, this is going to break stuff, right? So please make sure if you want to implement this, if you can pull this off and implement this in an enterprise environment, this would dramatically increase uh, your defense or defenses against enumeration attacks or enumeration. But please test it before you actually implement it. Now, another interesting script from the same guy, Itagredi, is called SAMR I10. SAMR is the protocol used by the net executable, right? For example, the Active Directory module or the Power View, both of these uses LDAP, but our net user or net.exe uses another protocol called SAM remote or SAMR protocol. There is a SAMR I10 script by the same guy which can harden server 2016 and 10 against enumeration, which uses the SAMR protocol, right? You can get the script from there. So that is all about the enumeration part using command line. We are going to, if you recall our methodology diagram, it is a cyclic process. So we are going to keep coming back to enumeration part whenever we get access to a new user or a new machine, right? Hope you enjoyed the video. That would be all for this.